Hello, my name is William Parker. I conducted research at Duke University for almost 30 years, retired as an associate professor. I am now CEO of WP Lab, which conducts research and education on the underlying causes of chronic inflammation-associated disease. In my discussion today, I'll look at the evidence which allows us to conclude, without reasonable doubt, that acetaminophen exposure early in life causes many, if not most, cases of autism. Our conclusions are published in the peer-reviewed scientific literature and are based on our own work as well as the published work of many other laboratories. We are well aware that other causes of autism have been proposed and strongly supported, unfortunately, in a premature manner. We are certain that this is not the case with acetaminophen, and we're confident that an objective evaluation of our reasoning will suffice to convince the unbiased listener. So I'd like to show you our team. I work with pharmacologists and blessed to have these guys on our team, pharmacologists and toxicologists with years of experience, as well as a number of scientists in the academic sector. I especially work with neuroscientists who are very important in this endeavor. My background is in chemistry and biochemistry. It's not in neuroscience. So Stacy Caroline Smith is an investigator at Duke University who's a postdoc in Stacy lab. And we now work in Kate's lab. John Van Ryzen is a postdoc in her lab that we work with. And we've also had great collaborations with other academics working in both information science as well as in sort of the epidemiology sector. So I'd like to tell you a little bit more about the team here at WP Lab, just so you get a background, an understanding of what our science is all about. So during my 27 years and 11 months at Duke University, I was very blessed to have a number of fun and I think important discoveries. We did discover the function of the human vermiform appendix. I worked with a good friend of mine named Randy Bollinger when we discovered that it is a safe house for beneficial bacteria. And that's something that Leonardo da Vinci had worked on 400 years ago. Now, of course, back then they did not know what symbiotic bacteria were, so Leonardo da Vinci had no chance of figuring out the answer to that question. But we were in the right place at the right time and did figure out the answer. I've also worked a lot on microbial evolution in the gut. It's an interesting problem and explains a lot about why we have digestive problems and other chronic immune conditions that we have. It also explains quite a bit about why it's so hard to develop therapeutics out of bacteria to address the problem. I was one of the pioneers in working with immunity in wild animals. I remember when we first told the administration that we wanted to bring wild animals into Duke, there were some very serious concerns about contaminating all of our super clean laboratory animals, and those, of course, had to be dealt with. You can't ruin everybody else's research for your own. So that was a great project. Just a couple of the papers there are listed. The papers are listed in a light-colored font on the PowerPoint presentation. A couple of the many papers that we published on that topic. And then more recently, we worked with protein folding, and I actually started that project back in the late 1980s, and we're still very interested in it. And one of my high school students in the laboratory was fortunate and actually got to the finals in the national competition and science fair and was able to shake hands with Barack Obama, president of the United States at that time. So that was a fun experience for both myself and for our students. And very recently, I've been working on symbiotic organisms and how those affect brain function. We actually discovered that these organisms are very important in the problems we have with anxiety and depression. And it also offers us some solutions that we might consider for therapy in the future. And then finally, very recently, I was the first to predict that COVID outcomes in the clinical sense would be much less severe in developing countries. And that did prove to be the case because individuals over there are protected by symbiotic organisms. And this is with adjustment for age and so forth. a lot of fun science that over the years, I'm not going to talk about that today. Again, it's important, I think, that you understand where we're coming from as scientists here at WP Lab. So I'll next go on and talk about my colleagues. They've got 30 plus years of combined experience in the pharmaceutical field. And none of my academic collaborators have that, and I don't have that. It's wonderful to have them on board. In fact, Dr. Jones, more than 25 years ago, was looking at the effects of nicotine on neurodevelopment. And when I say neurodevelopment, we're talking about how does the brain develop and how do chemicals affect that development during very early childhood. And it can also be in pregnancy and in utero. So there will be 3 parts to the lecture. We'll talk about the evidence first. I will focus the discussion for caregivers and non-scientists, although I'll provide lots of references so anyone that wants can dig in and read the original studies and look at the actual raw data. And there's going to be almost 20 lines of evidence. There's between 17 and 20, depending on how you divide up and categorize the evidence. I think today's lecture has it divided into 19 categories. But there's quite a bit of different lines of evidence, mostly independent, that we'll go through to show you how we reach the conclusions that we reach. Then we'll talk about, in the discussion, I'll mention that there's things that we can do about this. I can't give medical advice, and we'll reiterate that, but I can tell you about what the literature says regarding treating fevers and pain and such. Then we'll have a summary of alternative views, which are not correct, but I think they're accepted or at least embraced in some places. So we'll have to take a look at those. I think that'll be very important. So just in terms of the actual conclusions that we've reached and putting all the data together, we've got in the lower right hand corner of the PowerPoint, that's our 2017 paper on the topic, reaches the same conclusions. We're more confident now than we were then. We can state things more strongly. And that was our most recent paper, at the top there in Minerva Pediatrics. When we talk about evidence and we talk about putting all the evidence together, we're considering any kind of evidence that we can find. So it doesn't have to be from one particular field of science, but we do want it to be scientific evidence. So for example, an anecdote does not count as evidence. So an anecdote is just a piece of data with no context. A great example of an anecdote is a man died after drinking a glass of water. Now that's information is not really helpful because people dying is very common, and water is the most common popular drink on planet Earth. So it doesn't tell us anything. Even if we say, well, 20 men died after drinking 20 different glasses of water, that still doesn't tell us anything. But if I say they were all in the same room at the same time, now then suddenly we have something concerning. So now we have a context for the data. There's an association between drinking that water and death. On the other hand, if we find that, well, they're in a war zone, they were all wearing military uniforms, and there's evidence that a bomb went off in the room, we're not really worried about the water that they drank. But if they were all wearing business suits and there's no other signs of physical harm, then we begin to wonder what was in the water cooler, and the detectives will go look for means, motive, opportunity, and hopefully eventually track down a culprit. And that's essentially how we're approaching this. So there's a lot of different ways to gather data and to look for signs that something is indeed causing autism. You can find additional information about these things on other papers that we published or on our website at wplaboratory.org. So I'll start off now and just go through all of the evidence that there is, that we are aware of, I should say, of course. We'll number that evidence in 1 through 19. Most of the evidence is independent. I think there's 2 pieces of evidence that are linked to 2 others. So this would be 17 independent lines of evidence. And I'd just like to start out and mention that this might sound like a conspiracy theory when somebody says, wow, the world's most popular drug in children is causing autism, but it's not. And one part of me wishes that it was, because it's just such a tragedy. On the other hand, there is an easy solution for this one. So it's this, I believe, is at least where we are right now, we're in a good position to do something about it. So that's on the positive side. But there are fundamental differences between a conspiracy theory and between a scientific theory, or a scientific conclusion in this case. And I think one of the main differences is you've got a lot of different supporting evidence coming in from different parts of science, and all that evidence is available. It's not hidden behind a corner in some secret document somewhere. You can freely get this information. And again, if people are interested, I will I'll provide the references as we go through this. So our first line of evidence is, and again, one line of evidence by itself is not overly concerning, but when you put them all together, they are. So we'll go ahead and just start out with the first line of evidence. So the first line of evidence is, if you look at all of the different things that are associated with autism, all the different quote unquote risk factors for autism, they all have something in common. We talked about this in our 2017 review. They all cause oxidative stress, or this is a situation where the immune system, the metabolism just can't keep up. Oxidation is what happens when your body biochemically burns something. That is a basic process. It's a normal process, but when your body can't keep up, there's too much going on, and this relates to genetics. It relates to problems with vitamin B metabolism, for example, and it relates to a lot of other conditions, including being male or just being born, for example. Preterm birth is certainly associated with oxidative stress. All of those things together create problems with metabolizing acetaminophen. So we expect that oxidative stressors will be associated with problems in metabolizing acetaminophen. So the overall model makes sense in terms of all the many things that are associated with acetaminophen. And I'm putting these in sort of a logical order. I needed to, right off the bat, explain that oxidative stress is what we call a cofactor. Um, these are not confounding conditions, and we might mention that a little bit later on. But the bottom line here is that even just skipping 2 meals can cause problems with oxidative stress and cause problems with digesting or processing, metabolizing acetaminophen. I should point out that acetaminophen is known as paracetamol in Europe and by dozens of other names throughout the world. So a second line of evidence is actually what happens when acetaminophen can't be metabolized properly. Now, there's the green arrows here show you, and it's not important to understand to exactly what chemical modifications are being made here, but it's important to understand these green arrows are what happens when the body safely processes acetaminophen. Now, this one labeled glucuronidation, now that's a pathway which just doesn't work very well in babies at all. Babies don't have that set up yet. It takes some time to get them set up. Sulfation is another safe pathway, but that does not work very well in children with severe autism. So they have problems detoxifying. Now, of course, what's cause and what's effect, we don't know from just this piece of evidence, but again, we'll add everything together and it will tell us. And then, of course, the glutathione dependent detoxification, that is also listed here as being problematic in children with autism. So what that leaves you with is this red pathway, which is the toxic pathway. And there's some other things that acetaminophen, also known as APAP, that it gets processed to, that causes problems with other pathways that aren't even noted here. So when you can't go down these green pathways, we expect there to be a problem. So that is a second line of evidence. Now, a third line of evidence is extremely compelling. And I'll just go through that evidence and consider that with all of the other evidence that we'll look at. So the story is well known. Dr. Stephen Schultz has published the story. It's available on Amazon at no charge. What happened was his son took the MMR vaccine, then regressed into autism. And he quit his dentistry practice, went back to the University of California, and got his PhD looking at what might have caused his son's autism. And what he found is shown here, that if parents give their child acetaminophen, they are 20 times more likely to have child regress into autism than parents who do not give their child acetaminophen. There's the odds ratio was about a factor of 20. Now, the study is very small. It's extremely concerning, but by itself, it's not conclusive because it was a small study and the error bars are large on this. And the question is, well, why don't we just simply analyze a big data set to see if Dr. Schultz is correct? And the answer is that it can't be done. And this is one of those cases where I'm just going to show the data, put the data out there. I'll give you the bottom line. And if you're interested in looking at more detail, you're welcome to check those references. So the short answer is that somebody tried it, but it's not valid. That is the answer. So, I'll show you the reference for this in just a minute here. The Danish cohort, which is over 60,000 children, was analyzed, and a small risk, odds ratio of 1.3, which means there's roughly a 30% increase or 30% more autism, not increase, because it's an association increase, or there's 30% more autism in children who were given acetaminophen as babies compared to children who were not. Now, there's a lot of problems with that study, and you'll see that the confidence interval, the CI, is huge. Maybe there's only 2% more. Maybe there's 60%, 66% more. You can't really tell, even after looking at over 60,000 children. So why is that? What's the real number? So we worked on this with a professor of statistics. This is at Duke University, and Dr. Jones also repeated all of the studies. He's a very good statistician, and we're grateful to have him on the team. And I'll just show you the rundown of how we did it. You can screenshot that information. There are the references. And what we found was that even with computer simulated data, in which case we know that 2/3 of all the children got autism from acetaminophen. Now, it's computer simulation, so it's not real, but it's absolutely correct. I mean, we made it so that 2/3 of these children were getting autism because of acetaminophen. We ran the multivariate analysis, and it just showed nothing significant. As long as 70% of the people were using acetaminophen, then it's, even though 2/3 of the children got autism from acetaminophen, the analysis showed that acetaminophen is not significantly dangerous. And you wonder how that would happen, and it's, the devil is in the details. But let's just say that when a lot of people are using acetaminophen, even people not at risk, without, they don't have oxidative stress, they're not at risk for getting autism, and a lot of those healthy people are using acetaminophen, then other factors which are causing the oxidative stress start to dominate the mathematical matrix of this analysis. That's basically how it works. And we're still on our third line of evidence. This third line of evidence is the Schultz study, which shows this 20-fold increase. And the way he did it was not prone to this error. There's some other problems with the Danish cohort that we're fairly certain that something is up with how they monitored acetaminophen use. It's extremely low usage numbers they report compared to another study that was conducted at the same time with the same population that focused on acetaminophen. So again, this is the third line of evidence looking at the Schultz data, and unfortunately, it's very difficult. I mean, it wasn't repeated by the Danish study. That being said, if it did show an odds ratio of 1.3, or 30% more autism with use of the world's most popular drug. So that is still concerning just by itself, but I think that's just the tip of the iceberg, and certainly our statistical analysis of this using computer simulation would demonstrate that that is truly the tip of the iceberg. So let's go on to our fourth line of evidence. Now, the fourth line of evidence is the prenatal connection. There are 14 different studies now looking, and this is used during pregnancy. There is some connection with autism. It's an association, and heavy use of acetaminophen during pregnancy. And well, why, if we're focused on mostly on postnatal, why are we considering prenatal? Well, we're considering everything there's available, and there's no magic switch that gets flipped at the time of birth when you go from prenatal to postnatal that makes a child impervious to acetaminophen. In fact, it's probably the opposite. So when the baby is separated from the mother's liver at the time the umbilical cord is cut, you no longer have the mother's liver there. And then I showed you earlier, babies' livers just aren't good at processing drugs in some ways. And then certainly the baby's liver is not normally going to encounter a drug such as acetaminophen because babies normally only encounter breast milk. So all of these studies are basically saying the same thing, that there is an association during pregnancy with certain neurodevelopmental outcomes. They do try to control for indication. And what that means is what they're trying to figure out, well, was it the reason you gave the acetaminophen or was it the acetaminophen itself? Now, there is a problem with that because, as I've pointed out before, the things that cause you to take acetaminophen, such as having an infection or taking antibiotics with an infection, those things might cause oxidative stress, which makes acetaminophen worse. So they're not really confounding factors. It's very tricky. Our modern approaches to analyzing these things is not really set up for this, and it is a significant problem. And we just do a workaround. There are other ways to figure out what's going on. I'll show you a lot more evidence. We're only on piece of evidence number 4 right now. So no study found acetaminophen to be safe. There was, as I'll point out, there was one of the studies that did show that it might be okay when used occasionally, but certainly heavy use is not good. And there's a number of problems in addition to autism that were associated with heavy acetaminophen use during pregnancy, especially the 3rd trimester. So it's, again, in some cases, it might be okay to use it for fevers occasionally. And I like to point out that that 13 of those studies are all saying the same thing, but yet they've been criticized heavily. So in the problems with the criticism, if you look at them, generally don't recognize that, hey, this is only one study out of a number of other studies. And they don't realize that a lot of the investigators are trying to sort out, was it the reason we took the acetaminophen or was it the acetaminophen itself? And regardless of how you try to sort these things out, it's the acetaminophen still looks significant. So I'll give you, this is one really great example of a criticism which makes absolutely no sense. So when paper number 8 here on the list came out, it came out with 2 other papers in the same journal. So there were a total of 10 papers present at the time. And what happened is the National Health Service, and this has since been taken off the internet, but you can still find it because things on the internet get recorded. So a bizarre criticism came out within just a day after they spent months on this study and said, no, there's nothing to see here. Now, that's technically true. Nothing is proven, but that doesn't mean that we don't need to worry about it, that we don't need to seriously consider the problem. And from reading that criticism, you can see that they did not actually read the paper, unfortunately. At least they didn't read the details of the paper before they wrote the criticism, because the paper is it's just a great bit of work that was done by some people who were very seriously considering the problem, and that it was not given its due respect when the National Health Service wrote about that. And furthermore, they didn't seem to know that there were a bunch of other papers saying the same thing that came out before this one. In the end, though, it looks like if we had to make our best guess, it looks like the risk is fairly low compared to after birth. The risk of prenatal exposure is pretty low. It's maybe not more than, it doesn't count for more than 10% of cases of autism, and definitely not more than 20% of cases. And again, it's only with very heavy use of acetaminophen, which is not as common as the standard use of acetaminophen in babies. And as I'll point out later, it looks like it doesn't take much acetaminophen in a baby to cause substantial problems. It's more the disposition of the baby to have a bad reaction to acetaminophen. So we're going to leave this point number 4, which is the prenatal connection. Again, we expect, because the mother's liver is not there to protect the baby, we expect that the fetus might be more protected by the mother's liver than is the baby without the mother's liver there. We're going to take a look at some associations in time. Now, there's lots of associations in time with autism. I shouldn't say a lot. There's a handful that have been touted extensively, and we'll talk about a couple of those. But there's 2 in this graph are shown, and one is there is right around birth cohort 1980, or children born in 1980, the rate of autism starts ticking up. Now, it's a fairly slow tick up until about 1990 when it really takes off, but it does tick up starting around 1980, and that is when we switched from aspirin to acetaminophen, because aspirin was associated with Reye syndrome in 1982-83, which would have affected children born about 1980. So that's one association in time. A second association time deals with direct-to-consumer advertising, when we basically became we as a nation and we as a planet became heavy users of pharmaceuticals. So, the advertising is extremely effective at convincing parents that if they're a good parent, they will use this drug, and that that was allowed by our legislatures, and it certainly had a big effect on consumerism and the use of drugs. So yet a third association in time. So now we're up to point number 7. This is our last association in time we'll look at. Has to do with data that were collected by the Autism Research Institute. Now, this had started back in the 1960s when autism was fairly rare. It was, as far as is known, it was so rare the government wasn't tracking it. It had been defined much earlier, and we'll talk about that in a bit, but it was staying at a fairly low level. Here we're just looking at the number of reports received by the Autism Research Institute. About 1980, birth cohort 1980, they began to take off, and then they shifted. There was more regression versus infantile autism. And infantile autism is you've never seen the baby develop it, and never seen the child develop. It looked like they were born with autism, whereas regression, as we mentioned before, means that the child was developing to an extent and then lost some of those developmental milestones and was eventually diagnosed with autism. So what this data tells us, that it looks like something was introduced into the environment, into the ecosystem of the baby, if you will, that is causing regression into autism even after the baby's brain had been developing to some extent for up to a period of years. So this is very important, and it's consistent, of course, with the introduction of acetaminophen into the ecosystem of the baby's body during this early development. Very, very interesting, and surprising to many people, observation is that acetaminophen is a blunt social awareness in adults. Now, again, a lot of physicians don't know this, but there's been numerous papers published on the topic. I've got 4 listed there, and then a 5th one listed on the next slide. So, of course, hallmark of autism is difficulty with social awareness, or profound impairment in some cases of social awareness. So the fact that you see this in adults tells you this drug is somehow, and we don't understand the neuroscience of this, but somehow this drug is affecting social awareness. It's even been called a social analgesic. This is a very recent paper that has come out. So this is a separate line of evidence, and if you look, unfortunately, acetaminophen itself causes oxidative stress, so it looks like it could become a vicious cycle. It does cause oxidative stress in adults under certain conditions. So that is itself a problem potentially, and again, we can't extrapolate exactly what's going on in children, but it's very concerning, and it is yet a separate line of evidence. I'm going to switch gears now a little bit and look at laboratory animal studies. We're going to lump a lot of those laboratory animal studies into this one issue of behavioral changes in laboratory animals. And I think the best data that has been published on this topic is not from my lab, it's from Henrik Weiberg's lab. Henrik did a great job, and I think it's worth going through these data. We won't go through a lot of data, but you have mice. Henrik had mice, and he had controls which are given injections. You don't have to worry about placebo effects because mice don't know what you're giving them, but you give them this placebo because maybe doing all these injections when they're tiny pups could hurt them. So the controls, what you can see in that top graph is that after they've been injected with saline, which is the gray bars, once they get older, they can learn how to run a maze. So the top graph tells you that they get faster and faster at running the maze. The bottom graph tells you they make less and less mistakes running that maze. And it only takes 2 days, right? The first day, no training, and then day two is 1 day of training. Day three is after 2 days of training. They're extremely fast and they make almost no mistakes. Now, if they've had just 2 doses of acetaminophen, and these are not high doses, these are fairly comparable to what we give to human children, their their intelligence drops profoundly. They can't learn how to run a maze to find food. And this is something that's basic to a mouse's nature, that it knows how to find food and it gets better at it in a given environment. So very profoundly disturbing report. What this means is that if acetaminophen were tested today, it would not be approved. So that's the bottom line. Acetaminophen was grandfathered in. It's got approval from back in the day before we tested things on animals. And I'll show you later. We've looked at how that happened exactly. The bottom line is, given these data, if it had to go through regulatory today, it would crash and burn. It would never be used in a single human child. All right, now these are data from my lab, and what you can see, and so Henrik gave a little bit higher doses than what is given to human babies. We gave exactly the same dose as to what's given in human babies. And what you can see here is that there's a pretty big increase. It's almost 40% in anxiety-related behavior later in life. And the p-value on this is off the charts. It means that what that tells us is that it's a very significant result in these laboratory animals. And again, we're treating these rats exactly the same way that we are treating, that it's approved. It's weight-adjusted dosing and everything for human children. So it's important to keep in mind that laboratory rats are super duper healthy. So they're well fed, they have lots of vitamins in their feed. I'll show you that in the next slide. But a lot of the babies that get acetaminophen are not. And these are very old data from quite a while ago. I mean, this is 1960s. We've known that if you don't eat, you just skip 2 meals, acetaminophen gets much more dangerous. And what this curve is showing you is it's a toxicity curve, and it shifts, which tells you that if you just skip 2 meals, so for example, if the baby can't eat breakfast, doesn't eat lunch, skip 2 meals, then hypothetically, just like in these laboratory rats, they're going to have a lot more problems with acetaminophen, and it will become more toxic. So again, we don't know that that's true in babies, but it's certainly true in laboratory animals when it has been tested. It hasn't been tested in baby laboratory animals, and we'll talk more about that in just a little bit. But this is a graph just showing you the vitamins that are in rat feed that we use in laboratory all the time. And I've been doing laboratory animal studies since the 1980s, and we just never think about this. We never think that, wow, there's 40 times more folate, which is vitamin B9, in the rat feed than the US recommended daily allowance for a human. Now, why is that important? Well, vitamin B is a big part of this whole big metabolism picture and how we process acetaminophen. In fact, 72% of children, and this is Richard Fry's work, 72% of children who have autism have these, it's called an autoantibody. It's this molecule in their body. It's related to an autoimmune condition that blocks the transport of folate into the brain. So that's just incredibly telling right there. And without folate, you're not going to be able to process acetaminophen correctly. So again, we're just on number 9 right now, but this is a fact that it's having this effect in laboratory animals, despite the typical health of these laboratory animals, is extremely concerning. Now, I'm not going to go into detail on this study. This is one of those, again, where if you want, you take a screenshot, look at this later. But the bottom line is, in smaller laboratory animals, 11 days old, the lethal dose is over 1,000 milligram per kilogram, which you think, oh, that's not concerning. And I'm going to show you some data in a minute that, well, that probably is concerning. But the bottom line here is that it doesn't affect the liver. Now, there's a long-time assumption that acetaminophen kills people by destroying their liver, and that's known to be true in adults, but at least in laboratory animals, is not true in very small animals. It's actually affecting the brain, as we could see from Henrik Viberg's study. Part of the original approval for acetaminophen use in children was based on studies in laboratory rats when they knew that it took more than 3,000 milligram per kilogram to kill a laboratory rat, at least to kill half the laboratory rats in the group. So we're only using 14.7 or 15 milligram per kilogram in a baby. It should be a huge, huge, huge safety margin, right? Well, that's what we thought. And this is the only unpublished data I will show you. This is from John Van Ryzen, who is working in Kate's lab right now, as I mentioned earlier. And I'm showing Peg McCarthy's picture here. She's the one that trained John. John's now a postdoc in Kate's lab, but Peg is the one that trained John. And you can see from his data that only 150 milligram per kilogram, and given 3 times a day, and you're allowed to give a baby repeatedly acetaminophen, you're allowed to give them up to 4 or 5 times a day, but only 3 times a day is enough to kill most of the animals. It killed 12 out of 14 in the study, and in the control group, none of them died. So this, and again, this is unpublished data, but I thought it was important we'd throw this in there just to show this drug is much more toxic. And again, these are very healthy animals. As far as we know, they don't have oxidative stress. They've been eating well, they haven't been fasted, or they haven't had to skip meals because they were sick or something of that nature. So super concerning data there, but not yet published. I look forward to publishing that data with Dr. Reisner's group very soon. Now, in the next slide, we'll look at some of the results from Dr. McCarthy's lab. She's chair of pharmacology at the University of Maryland, and she's found that drugs that inhibit the enzyme cyclooxygenase 2 or COX-2, those drugs tend to affect males more than females. So of course, that's yet a separate line of evidence. Now, part of the male effect may have to do with circumcision. Now, this is our next line of evidence. And what we can see here is that circumcision is associated with a 2-fold greater prevalence of infantile autism. So this is wildly concerning. The investigators that did that, Ann Bauer was the first one to note that this may be a problem, and then a couple of investigators in Europe really took a close look at this in a large Danish cohort and said, yep, this is a problem, and they think this may actually be an underestimate. So what this is telling us is that, putting everything together, there's this association between circumcision and autism, and twofold. So if you have 10 babies, they're all male, all circumcised, and all have autism, then, well, half of those may have been induced by acetaminophen use at the time of circumcision, which is very common. And again, I'm interpreting this association in light of our conclusions based on all the other data. And the circumcision connection is extremely compelling because we don't have another explanation for that. We don't think that a surgical procedure by itself would cause autism. There's no mechanism for that, or mechanism by which that might happen. And we know that the time of birth is particularly a time of high oxidative stress because it's when the body is just learning how to breathe. You're just learning how to transition from the mother's lungs to your own lungs. So it's known to be, in the scientific literature, a very tricky time. So 2-fold higher infantile autism, which is what we would expect. So of course, it's classified as infantile, but the idea would be they were born normally and then they regressed into autism before they ever had a chance to develop, essentially. Now, the parents sometimes don't know when their babies get acetaminophen in the hospital. It is often given at the time of circumcision because it's thought to be the humane thing to do. Sadly, acetaminophen does not work well to block the pain of circumcision. There is an epidemiologic association. This is another line of evidence. And so we're switching, it's related to the circumcision, but it's yet a separate line of evidence because it's independent. And what has been found is that the modern Jews who have adjusted their practice and use acetaminophen with circumcision typically have much more autism than do ultra-Orthodox Jews. Now, the ultra-Orthodox Jews do use wine or some form of alcohol, which is their tradition, as do the modern Jews. Now, unfortunately, alcohol and acetaminophen are just known to be a bad combination. Alcohol will will set up oxidative stress, and then the acetaminophen then of course does not react well with the body under those conditions of oxidative stress. So we think we probably have a good explanation. Now, there are other explanations. It could be related to the propensity of certain groups in Israel to seek out medical attention, but it looks like this is a good explanation for the data by itself. There's yet another line of evidence from South Korea where they've had repeated problems with the manufacturing of children's acetaminophen, and the manufacturing had to be shut down because they had too much active ingredient in the compound. And they think that they got away with it because they only monitored for liver function, but they do have extremely high rates of autism that have been documented there, and it's not due to some problem with the testing. I'm going to switch gears now. We're going to start looking at parents' observations. There's going to be a number of slides on this. We're going to sort of go back through the history of autism and parents and the medical establishment and look and see how this has been playing out. And I think this is among many things, this is one of the tragic occurrences that has happened with autism in the world today. So the parents' observations are yet another line of evidence that is pointing towards acetaminophen. I'll go through that in detail. So, of course, most people know that parents tend to blame vaccines for autism, and that depends on which study you look at. It can be up to 50% of parents who have a child with autism believe that that a vaccine was involved, not acetaminophen, a vaccine. So the question is, why is this? There's a beautiful study that came out of Europe looking at younger SIBs showing that even if you don't vaccinate, you can still get autism. So it's not the vaccine itself. And I think the epidemiology supports this. And of course, the vaccine wouldn't explain a lot of other things that I'm showing you. And the MMR vaccine that Wakefield was looking at doesn't have, we'll talk about Andy Wakefield in a little bit. It was looking at doesn't have the kinds of metals that have been variably associated with vaccines through time. So of course, the acetaminophen has been used widely in conjunction with vaccines. So there's the connection again. You've got no matter what the procedure is, whether it's vaccination or whether it's circumcision, you get acetaminophen and an association with autism. And of course, if you don't get the vaccine, you can still get the acetaminophen, and you still then, of course, have the problem. So the standard story is, as I mentioned before, this is Andy Wakefield's fault. So he published a paper. Most people don't even understand the title on that paper unless they're medically trained, but the press hyped it up as a potential connection between a vaccine and autism. It was a case report of 12 children. It has, as most people know, has been withdrawn or retracted from the literature by the editorial staff of the journal. And this is what the paper actually says. So it's a case report of 12 children. I've been to meetings where you could find hundreds of people giving the exact same story. I don't think it's hard to find 12 people with the story of their child got a vaccine and then regressed into autism. Steve Schultz, for example, is another individual who would tell you the same story. And so what they conclude is that further investigations are needed to examine this syndrome and its possible relation to the MMR vaccine. Again, MMR is a vaccine without any kind of metals in it. So the interpretation was retracted, and they didn't actually say there was a causal link, but they did issue a formal retraction saying there is no causal link. So that's a little bit unusual by itself. And I think this was driven by the fact that there was a fear of vaccines that was arising in Europe because of the study and more importantly, because of the press that it had received. And then it was finally retracted completely because of a lack of ethics board approval is one thing, even though it had already passed one sort of ethics exam or a review, and false claims that the children were consecutively referred. Now, this is a complex technicality, but nobody thought that these were the first kids that Andy Wakefield saw, but the other physicians would simply refer people to him when they fit the profile. And that of course biases the data, but it's a case report. It wasn't supposed to be a population study. So It's interesting that the full retraction happened for these reasons. And then he was eventually accused of falsifying data. From my own community, I can tell you that there's the anecdotes there could provide a couple of people for him to report on, and there's many. He had, I understand, about 50 more cases lined up when he lost his medical license and then couldn't publish it. So I don't think he had problems finding. I'm suspicious that he actually had to fabricate any data. There's just too many people out there, such as Stephen Schultz, with this report. And again, 50% of the people with a child with autism think that a vaccine had something to do with that. Standard story is that it just happens this way. That autism happens to develop at the same time you're given a vaccine. Of course, that would contradict the data that Schultz saw. And I think it's important to sort of take a deeper look at this and what's going on between the parents and the medical establishment. The parents don't trust the medical establishment, and the roots of that go extremely deep. And they go all the way back to Leo Kanner, who actually discovered autism in the United States. Asperger discovered that in Germany, but his affiliation with the Nazi Party sort of led to his data not being widely appreciated or accepted. So Kanner gets a lot of credit for discovering autism back in the 1940s, and unfortunately, he mistook cause and effect, which is something all scientists need to worry about. But he was not a scientist, he was a pediatrician and clinician. He mistook cause for effect and saw that the parents of these kids with autism, they were not very affectionate towards their children. Now, of course, they were at wit's end. We know they did not know how to relate to these children with autism. And unfortunately, then Bruno Bettelheim played a big part in this story because he propagated the idea that it was bad parenting, and the refrigerator mother hypothesis was born, which again tragically blamed the parents for the child's neurological condition. And you can see that interview, the bottom statement there by Leo Kanner is extremely unfortunate, but representative of the thinking at that time. So this is from the 1940s all the way up until 1964. And the top picture there, that's Bernie Rimland. And it's important. He'll be important. We'll see him show up again, but he's the one that finally did away with the refrigerator mother hypothesis. So he had a lot to do with it. He wrote a book. He had a child with autism. He wrote a book about his child's condition, and the popular views shifted. Leo Kanner shifted his view and understood then that he had mistaken cause for effect, and that it was quote unquote innate. In other words, that it was something within the child that did this, and that was again yet another, we now know, bad interpretation. And I'll point out that the autism that he was looking at was pretty rare. It may be induced by, it's almost certainly induced by something different than the very common autism that we're looking at today, which is 1 in every 36 children. The idea that it has to be innate, that you can't regress into autism, held sway in the medical community and the scientific community until 2005, when Geraldine Dawson, who's now director of the autism clinic at Duke University, published a paper and said, look, we've looked at this carefully, we've examined the videos in a blinded fashion, and the children are indeed regressing. So it is possible to regress in autism. So you've got a whole period of refrigerator mother hypothesis, and you've got another period all the way up until 2005, when the medical establishment did not accept that you could regress into autism. It was considered innate. So going back, we're still on this point 14 here, which is telling us that something is going on with the vaccination that is, and based on the Schultz study, we would say that is acetaminophen. But it is data that's independent from the Schultz study. These are surveys of parents who are looking at their own child. And it's not an anecdote, because they're collecting all of the parents in a given practice and doing a survey of all of those parents. So this is not telling us 50 parents, this is telling us 50% of the parents in a given situation. And the number varies. Sometimes it's a little bit less than 50%, but it's always a very large percent. So the parents' observations are supporting the other lines of evidence, which are telling us that acetaminophen or paracetamol use is associated with autism spectrum disorder. Again, the parents are strongly encouraged through advertising dollars. You see a picture of a sick child, you see a picture of the pharmaceutical product, and you see a picture of a healthy child. Very emotionally driven advertising saying if you're a good parent, you will use this product, which is allowed by law in the United States right now. So I mentioned some of the Schultz data earlier. This is connected to his earlier data, but it's a separate finding. So we're going to give this one a separate number. It's not independent from the other study that Schultz did. But what he found was that if you have a bad reaction to the MMR vaccine and you take acetaminophen, then there is an association with autism, but not if you have a bad reaction with the MMR vaccine and you take ibuprofen. So again, that's pointing at the acetaminophen in the connection. So when we first started working on this back in 2017, we kept getting papers rejected by pediatricians who just said, hey, look, everybody knows this drug is perfectly safe. You know, what are you doing? This makes no sense. So our next line of evidence is actually it's called a systematic review that we did. And this is a picture of Barry Rumack. He was one of the pediatricians. He's still working today, still a prominent pediatrician, looking at the toxicity of acetaminophen. Now, if you read Barry's work carefully from back in those days, he'll tell you, we don't know what the long-term effects of this are, and it needs to be studied, but nobody paid attention to that. Instead, they being the community at that time, decided it was safe because they did not find any liver damage. So there's a quote. I'll just pause for a second and read that quote. So the way that we looked at this was we collaborated with a bioinformatician, information scientist. So these are some of the students that worked on, these are all the students that worked on the project. It was months and months of labor digging through the literature. So you try to find every single paper in the medical literature that says the drug is safe. And then you have to track that back and say, well, why did they say it was safe? What did they do to say it was safe? So this is an example here. You can see in the box, there's one paper by Temple in 2017, and it says acetaminophen is perfectly safe for use in children. It cites a lot of other papers, which are shown by the lines linking to other papers. And then if they have a green check mark by them, that means that paper is an original source. It either has an experiment or just says, without qualification, the drug is safe. If that paper links to other papers, then that paper is using other papers as the source for authority. So a green check mark means they either have an experiment, which they say shows the drug is safe, or they are just saying the drug is safe without any kind of data whatsoever. And what we found was on the graph on the left, the follow-up time. So you give the drug and then you follow up to see if it's really safe. The follow-up time averages only 2 days. And that's not enough time to check and see if you get autism or ADHD or developmental delays or anything. There were a few longer studies that were a few days longer. One study even went out to a year, but nobody looked at neurodevelopmental problems. So nobody is checking. And of course, at this time, they didn't have, say at this time, when this all first started, back when Barry Rumack was working on it, they didn't know the data that they were unaware of the dangers that we can see in laboratory animals. So it's understandable at that time that they were just checking for liver function because that's how it worked in adults. I mean, it's hard to know what they should have known back in 1960, 1970. There are papers back in those days which say, hey, look, we can't treat babies just like they're miniature adults. Their metabolism can be different. But that was not the standard practice back then. The bottom line is nobody ever looked for neurological function. They just didn't think about it, didn't know to. It slipped through the cracks. It's truly a tragic situation. So we'll go on to another case, and we're winding down on the amount of evidence that we have. And there's a reminder here, the role of immunity oxidative stressors is that there's oxidative stressors that are always associated with autism, except for a notable exception, which is cystic fibrosis. And cystic fibrosis is a condition for which mental health has been monitored extensively in the past. Autism has not been found. It's never been reported. And this the thing about cystic fibrosis is that all of the oxidative stress is at the mucosal surface, and their brains are actually super efficient at processing acetaminophen. It's known that if someone has cystic fibrosis and you want to treat them with acetaminophen, you have to use more than is normal. So there's a compensating mechanism going on there, is what's been found in the literature. So the fact that CF is an exception is also consistent with the view that acetaminophen exposure early in life is causing autism. And then we'll go on and talk about the studies in some adult laboratory animals. This is one that we've added more recently. And it does turn out that even in adult laboratory animals, acetaminophen results in some death in the neurons, even before it becomes toxic and kills the animal. So obviously this drug should have been tested for neurodevelopment in babies and children and during pregnancy before it was ever approved. It was just before our current approval process. There is a study with cord blood acetaminophen. Now, the odds ratio on that is 3.6. The confidence interval is at both ends is extremely concerning. And what this shows is if you have the highest third of levels of acetaminophen in the cord blood, and the cord blood is essentially the baby's blood when they're born. So the highest third is associated with a much higher risk of autism than is the lower third. And this is a bigger risk than what we see with use during pregnancy. And again, we think if you look at the circumcision data, this is telling us, hey, the time of birth is a really, really risky time for giving this drug to an individual. The way that we look at this is that the evidence is just overwhelming. There's no question about this in my mind that acetaminophen is causing many, if not most, cases of autism. Now, we don't have absolute proof in the sense that no study has been done with placebo controls, and it's a very difficult, if not impossible, to even envision a placebo control with this drug because it's such a great and effective anti-fever drug. You know if you're getting the real thing or not because it reduces the fever so well. But even though we don't have absolute proof, and in the past the government has not provided funding when we've been interested, and I don't think in hindsight we'd really even want to do this experiment because we have so much evidence that this drug is bad. If we did the formal experiment for proof, we would have to give a bunch of children this drug, and I don't think that's a good idea. It would be similar to trying to find formal proof that parachutes save lives. So that formal proof has never been done. You'd have to get 100 volunteers and give them all a backpack and tell them, well, there's a 50-50 chance you've got a parachute, and it might just be nothing. And then have them jump out of an airplane, right? And then that would give you formal proof that you'd have 50 deaths of people without parachutes, and that would be formal proof that parachutes save lives. But it would be an unethical study, of course, and certainly you would never get any volunteers for that. So I think looking at all of this data together, you don't need that study. There's so many things that you have to invoke to account for all of these data if acetaminophen is not causing autism. So let's take a sort of a look back historically. I think it goes back 80. It goes back 80 years, and you've got 40 years where after Connor first discovered it, and it was fairly rare. It wasn't diagnosed very often. We're going to talk about there's been some assertions that, well, it was very common back then. It was probably still 1 in 36 or some high number back then, but we just didn't see it. Now, Connor was smart. He had just written, well, he was smart in terms of diagnostics. He probably wasn't smart in terms of figuring out mechanisms based on his refrigerator mother hypothesis, but he was smart in terms of diagnosing conditions, and he had just written a book about pediatric diagnosis, and he was confident, as was Asperger in Germany, that was a relatively rare condition. So unfortunately, then Bethlehem was there pushing the refrigerator mother view, blaming the parents. And then 1965, Remlin came out and said, no, no, that's not what's going on. And then Rumack in the 1970s and the pediatric community in general saying, look, acetaminophen, Tylenol, that's drug, it looks pretty safe. It's not killing the baby's livers, and therefore it's looking pretty safe. We now know that's unfortunate logic. And then 1980, that's when aspirin was associated with Rye syndrome. So we switched from baby aspirin to infants Tylenol or Calpol or any other number of formulations that acetaminophen or paracetamol is known throughout this little planet. Then it wasn't until much later that Wakefield came along and said, hey, look, I'm seeing in some of my patients, some of the patients that have been referred to me are reporting that they got a vaccine and they regressed into autism. What's up with that? Bernie Remlin, this is the same Remlin that you see back there in 1965. Remlin came along after Wakefield and supported Wakefield. He said, look, there looks like something with the vaccine. And it was a tragic misinterpretation. Remlin lost. He carried all of his weight in the community of parents with autism into that statement. And, his reputation suffered for that. But he was just listening to the parents. And please note that Geraldine Dawson didn't come along until later and say, hey, regression can actually happen. So Wakefield and Remlin were talking about this at a time when the average pediatrician may have considered that autism has to be innate, you can't regress. And it was only later that Steve Schultz, who was he was the first to sort this picture out, did a beautiful job. And then almost all the evidence that I've shown you is from much later in the time frame. So a really tragic story. I gave this talk at Duke to a number of faculty, and the question is, who's the villain here? And it's a bunch of very good intentions. It's hard to point to. You can certainly identify the mistakes, but it's not necessarily trivial to identify. And some people are going to disagree with me on that, but it's not trivial, at least in my view, to identify a villain in all this. And back in my day, Walter Cronkite would say, and that's the way it is. So taking a step back, it's important to know that for most children, you don't see a big impact from acetaminophen. You've got to have these other risk factors. So the anecdote, it's called the anecdote bias. My grandmother smoked for all her life and lived to be 100, so therefore smoking is okay. We know that that's a false statement. But the point is that because one child does well, or even most children do well with acetaminophen, does not mean the drug is okay. It does require this issue of oxidative stress. I think during pregnancy, especially later in pregnancy, it is a risk factor with heavy use. The data pretty strongly support that, and I won't say that that's conclusive, but it's extremely concerning and very strongly supports that. Whereas we can say it's very conclusive that after birth, there is a problem, and that acetaminophen is causing autism in susceptible babies and children. So one of the questions I get asked, well, why do you think it's worse after birth? And we've addressed that to some extent. I'll just put up a list of our reasonings here. I mean, the studies in animal models, I showed you our new data coming out of Kate Reisner's lab at UNC. It's 150 milligram per kilogram being lethal. That is not what we expected to see. The fact that all the animals were dying sort of slowed down the study. So the next question is what to do about it. I'll be very quick to point out I cannot give medical advice. I can tell you what the literature says. I can't answer the question, what would you do if it's your child? My wife and I don't have children, so we don't have a dog in this fight. So this is the way they say it where I grew up in Arkansas. Generally, people are, and it depends, this is a study out of Sri Lanka, generally people are using acetaminophen to treat fevers. So one question is, well, could we just use a bit less acetaminophen? And that these data, they're old data from the 1970s, and they basically know you can't use less acetaminophen because it won't treat a fever. If you right now, so you see that this graph shows fever reduction at 20 milligrams per kilogram, which is pretty good, at 10 milligram per kilogram, which is much less, and then at 5 milligram per kilogram, which is not very good at all. The current recommended dose is 14.7 milligram per kilogram. Since you can give it repeatedly before it's completely out of the system, the drug level will go up in the neighborhood of 20 milligram per kilogram, which is very effective. But if you cut it down just by, say, a third or a fourth, it's going to drop too low to do any good. So you can't just use less. The better question is, should you use any at all to treat a fever? And again, I can't give medical advice, but I can say that the scientific literature says that a fever is protective in a lot of cases, and in fact, is part of your immune function. So if you treat a fever, you are immunosuppressing the child, which is, you know, not necessarily going to improve outcomes. But I think it's important that we keep in mind that the fever is not the bad guy; it's part of our immune system's defense. And when you get rid of that, you can cause problems, and the scientific literature supports that. So then, well, what about dangerous fevers? Well, the bottom line is we know that most fevers are not dangerous. And then this paper will tell you that, well, if a fever is actually dangerous, acetaminophen may not work very well to protect the child. So, especially in cases of brain injury or whether you've got an infection in the brain, those kinds of fevers are associated with something that's extremely dangerous. And it's not necessarily the fever itself, although fever is associated with inflammation, which can be the enemy in these cases. So the inflammation, the fever work hand in hand to fight an infection. If they get into the brain, that's going to be a problem. And again, there's no scientific evidence that acetaminophen is an effective way to prevent these kinds of dangerous fevers. Now there was a website that's posted. You can find it, but it's in a web archive. It was taken down and redirected to a site which encourages use of acetaminophen. But there was a website promoted by the Academy of Pediatrics which showed how to treat a fever without using medication. So again, no medical advice here, but the information is out there for those who are interested. So that's the end of that. We'll now go on to a summary of alternative views, the final part of our a lecture series. Now this is the latest data that came out of the CDC. It's 1 in every 36 children has autism. So the question is, well, what's doing this, or is anything doing? Is there anything real to see here? So we'll go through and sort of look at a summary of alternative ideas. Now, it could, there's been several other things. We talked about vaccines a little bit, but what's causing this? And Erin Baker is one of the many scientists that works on, environmental pollutants. And this figure is taken from one of her papers. She does a great job of illustrating things. And you can see there's general categories, and one of those is pharmaceuticals that gets out into the environment, and is also, we put that intentionally into our bodies, and the other things are more or less out in the environment that will accidentally get into our bodies. And so the question is, well, what about all of these other things? There's thousands of other things, literally. And so far as we know, there is no other viable alternative. Now, there is an extremely well-known scientist, Philip Landrigan, who's been working on children exposure, and he is well aware that children are more sensitive to these things than are adults. And he talks about 11 developmental neurotoxicants. He does a great job with this, extremely renowned individual. And his point is that there's 11 that we know about, and if you include ethanol, that would be 12. But and as far as industrial pollutants, he's talking about 11. Acetaminophen is not on the list. It's some people have thought that, well, he's talking about things that might cause autism, but no, not necessarily. There's a great commentary on his work by James Hamlin, a medical doctor writing for The Atlantic, and he put it extremely well. it's not about those 11 or 12 if you include ethanol. It's about the fact that there's so many out there. There's hundreds that we just have never tested on neurodevelopment. And the question is, well, what is it that really coincides with what evidence can we put together? And I just showed you a lot of evidence pointing at acetaminophen. I think conclusive evidence pointing at acetaminophen as a cause of autism. So we'll go look at another sort of suspect here, and this suspect is glyphosate. It was originally patented as an antibiotic, but it's used as a herbicide. It's put on a lot of plants, food plants, and of course it's associated with. We can use it in genetically modified plants because they are resistant to it. So that's allows us to use a lot more of this chemical because we don't have to worry about killing our food because our food is genetically modified and resistant to it. So you can see here that the prevalence of autism, the measured prevalence of autism, is associated with the amount of glyphosate that is being used. It's an association. This is a true association. If there is causation, you have to have this association, but does it really make any sense? Of course, the answer is no, we don't think so. I mean, there's no way glyphosate could account, for example, the connection with circumcision or the connection that the parents were seeing that Steve Schultz saw with the vaccination. So let's also look at the toxicity data from the animals. Now, in animals with acetaminophen, in Henrik Weiberg's studies, he only used 30 milligram per kilogram, which is twice as much as we give the kids. So the ratio, the typical exposures to babies versus the exposure to cause severe neurological injury in laboratory animals, only 1 to 2. And again, this would mean this drug could never get approved in today's world. And and it obviously something needs to be done about its current state of approval because it's not productive. It's in fact tragic. But so the ratio is 1 to 2. Now it's really hard to calculate the same ratio for glyphosate because we don't know exactly how much glyphosate people are getting in a single dose. We do, and even in laboratory animals, they don't give them an injection, a specific dose. They put it in their drinking water. But if we compare how much we expect to be in our food compared to how much it takes to cause in the drinking water from laboratory animals, what we see is a big difference. It's not 1 to 2 anymore. It's 1 to 65,000. This is a very, very rough number, but it's a ballpark number. It tells us that, look, this drug is not nearly as toxic at the doses we're giving it as acetaminophen is. Okay, now I'm not saying that's a great idea to have lots of pesticides in our food. That's not what I'm saying, but I am saying that it doesn't look like this thing causes autism. Right? It's just, and we can do that in a laboratory animal. We can show they're fairly resistant. Now, there's another way to look at this, and then that is, well, how much, say, would a baby get in breast milk versus how much acetaminophen do we give somebody? So if we look at that, how much glyphosate does a baby really get? So if you measure the amount of glyphosate that's in breast milk in a part of the world where they're during the season where they're using glyphosate and they're probably eating a lot of glyphosate on their food, they're putting it on the crops in the area, in a rural area, what you find is that they're getting 0.000069 milligram per kilogram in the baby. That's the dose that the babies get. It's a weight adjusted dose. Now, that is 213,000 times less than the dose of acetaminophen that we give to the baby, which is 14.7 milligram per kilogram. It's a maximum allowed dose. But I mean, 16% of all doses, one study showed, even in the hospital or at home, are overdoses of acetaminophen. So people are just so comfortable with this drug that it's frequently overdosed. And people ask me, well, was it the overdose that got them? I mean, is it only kids that are overdose? We think it's a combination of how much drug did you get and how much oxidative stress, how much risk do you have, right? Do you have that autoantibody that 72% of kids have that blocks folate from getting into your brain, at least to an extent? So it's, again, back to this idea that it's some alternative. We just don't have a good alternative. I think glyphosate is certainly not it, and nothing else that's been suggested is a good alternative. So another alternative view is that, hey, maybe it's just the genes that are causing autism. But if it was genes that are causing autism and the genes are also causing you to use acetaminophen, first of all, we would have figured out, I think, we in the scientific community would have figured out what those genes are. They can't be found, number one. Number two, you wouldn't see these kind of associations that we see. Why do circumcised boys have twice as much infantile autism as uncircumcised boys, twice the prevalence? And there was a great study in Vietnam showing that people exposed to a lot of oxidative stressors in the fields where they're using a tremendous amount of pesticides, they have much more autism than people who are working in the office. So they don't know why that is, but certainly the oxidative stressors are there. And bottom line is, if it was genetics, then it wouldn't matter what your occupation was, unless of course genetics determine occupation, which they don't. So this one is just not possible. All right. So another alternative view is that you have to be born with it because we can see signs of it. Now, I'm a biochemist by training, but those quote unquote biomarkers that people are seeing when they're saying, hey, we saw this when the kid was born, even though they regressed later into autism, those are biomarkers for oxidative stress. So because so many people, especially sicker people who have oxidative stress, are getting acetaminophen, you look at the biomarker, these biomarkers have long been known to be markers for oxidative stress and inflammation, which go hand in hand. Excessive inflammation will lead to oxidative stress. So you're looking at, yeah, they're biomarkers and they're going to predict autism, but they're not biomarkers for autism. They're biomarkers for sensitivity to acetaminophen. So it's partially true, but partially not true, and certainly misleading to say that the biomarkers are telling us that they were born with autism. That is not correct. So this is a statement that was made in a journal which is not favorable to the idea that acetaminophen could cause autism. And unfortunately, right now there's a sort of ideological battle in this field, and there's tremendous conflicts of interest. If we're right, and I'm convinced we are, there's labs that will be shut down because they've missed it. We can easily prevent many cases, if not most cases, of autism, and it will just be less important to study, much as we don't study scurvy now because it's so easy to prevent with vitamin C, with citrus fruit. So they actually used the word truth in this article and said the truth is that it just can't be. And that is not science. There's no way to construe that as science. But it is an unfortunate reflection that we do have an ideological battle going on right now in the field, in the scientific community about this. So another common thinking is that, yeah, hey, there's a lot of things, just increased awareness can cause increased diagnosis. If you put money into a program, it will cause increased diagnosis. And there is no question that this is absolutely true, right? That if you put more money into a program, you'll get more diagnosis. The physicians are more aware of it, you will get more diagnosis. At the same time, working with Cindy Nevison, we've looked at this very carefully, and we expect there to be some lag. If it goes from 1 in 2,500 in 1970 to 1 in 36 today, there's going to be some lag, and the system's going to have to catch up, and you're going to have to get more awareness, and you're going to have to get programs up and running to help people, and that's going to cause a delay. There's going to be a lag. We would expect that. So this is the fact that these things do cause increased diagnosis don't prove anything. And again, you go back to the Schultz data, you go back to the parents' observations, you go back to the circumcision connection, you go back to the toxicity data in the animals. You've got so much other evidence telling you, hey, there is something real here. And the bottom line with this is that it is true, but it doesn't account for all of it. And look, we've had 40 years of an increase, right? How much increasing awareness do you need, or how much programs do you need to get the diagnosis up to the right number? Now, when you look at the current 1 in 36, the ratio of severely and profoundly affected to the ones that are not, it's still about 50-50. So it's not that we're just picking up the more sensitive cases. I've seen some people arguing that, well, hey, there's a lot of folks that have an autism diagnosis, but they have this other diagnosis. And if you go back to 1970, it would have just been they would have just been diagnosed as this other thing. That is speculation, right? We're assuming, which we can't do. We're assuming that that other diagnosis would have been connected with autism back in 1970. We think, for example, that with Down syndrome, the prevalence of autism in that community is going up and up. So I think that the prevalence of autism with other conditions is changing. So you can't assume that if you go back in time that it was just diagnosed as those other things. It doesn't make any sense. And again, in the light of all the other data I've shown you, especially look at the data from Vietnam, there's something in the environment that is causing that autism, and it's quite profound. The data from South Korea is telling us the same thing. So this idea that many other factors account for the rise of autism, yeah, we do have more oxidative stressors now than we have in the past. Even psychological stress is an oxidative stressor. So that is true, but those oxidative stressors then make us more sensitive to acetaminophen. So yeah, it's true, but then again, it doesn't mean that it's not true that acetaminophen or paracetamol is causing many, if not most, cases of autism. So one great argument that I saw was, hey, fetal alcohol syndrome was only discovered in 1972, very recent, even though alcohol consumption has been around for 10,000 years in multiple societies. So maybe people just weren't that good at detecting these kinds of things back in the day. And the thing about fetal alcohol syndrome is that it also needs a cofactor, which is inflammation, chronic inflammation. You can there's nice animal studies which show that if you block inflammatory processes, you will block fetal alcohol syndrome in those mice. So one issue is that we do have more inflammatory mediators in our society today, going back to the pesticides, for example, and that is going to be a problem with alcohol consumption in terms of neurodevelopment. So this one it's definitely true, but it's somewhat misleading. It's not telling us that there's that the that Leo Connor and the other physicians in that day just weren't aware that people had autism and were lacking social awareness. All right, and then another idea is that somehow being autistic is important for traditional human societies. These are hunter-gatherer societies. I've I've done a lot of work with scouting, decades of work with the scouting, and I'm a fun thing to understand these techniques that hunter-gatherers use to build fires, to catch food, cook food, and making spear points or fishing. That's something that neurotypical people can do quite well. There's no evidence that this is a interesting speculation, but there's nothing that anyone knows of that a person with a severe and profound lack of social awareness could do better than a neurotypical person. And that's, of course, the hallmark of autism is the lack of social awareness. That's probably not going to be productive in any kind of hunter-gatherer society. Even if you could fish just as well, how do you then share your fish? How do you work with the group to determine when you go fishing and when someone else does? And the social setting that's basic to most mammals. So the alternative views really don't take into account the facts, the diverse range of evidence. And the arguments that there is no real increase in autism, I mean, there's real increases in so many things in children, that peanut allergies, for example, and we accept that's a real increase. So why does one inflammatory condition have no problem getting acceptance, and then another inflammation related condition, which is autism, has so much trouble getting acceptance as a real problem? I mean, if you had an infectious disease that was harming 1 in 36 children, it would be, can't even imagine how important that would be, and this is, even though this is being sort of swept under the rug, hey, we just need more resources, there's really nothing to worry about in terms of the actual problem itself. So they don't explain the numerous observations that I've pointed out. And I think it's important to understand that scientists, both in the academic sector and in industry, have profound conflicts of interest. I mean, our lab function depends on us being right. We need to be right. We need to get more money. We need to say, hey, what we're doing is important. So there is a conflict of interest there. There's no question about that. And at this point, I think because of the profound conflicts of interest, because we haven't objectively backed off and looked at the data, what you see is that there's kind of an ideological battlefield. And the top quote there is one that I've already shown you. It was published in a journal. Scientific journals don't usually use the word truth unless it's a journal in the social sciences looking at religious studies. The next quote is from a popular magazine, but I included that quote, the base rate of autism isn't magically rising because there's some toxin that's causing it. I included that quote because it was a quote from an editor of a prominent journal that is specializing in autism. So that tells you that there's some kind of ideological battle going on here. I think we probably need to go more, we need to look at the data instead of going by blind faith on this one. This is so important. And you know, the quote from our 2017 paper is here. I'll just let you read that. Our opinion has only gotten stronger since that time. All right, so I'll now conclude. I'll thank you. You've stuck with me through this whole entire 90 minutes. I hope you found it both interesting and well thought through. I think we've done a good job. We didn't rush into this by any means. We've been working on this for a number of years. We've thought through a lot of different angles on this and worked with a number of great neuroscientists on the topic. And we're grateful to their support. You see a lot of the students here on the acknowledgement slide that put in so many hours on this thing. Like, thank Stephen Elson is the one from the Autism Research Institute that gave me that data, and he and I went through that data together, looking at that early uptick that almost doesn't show up when you look at the big graph, but that early uptick from birth cohort 1980 on to about 1987, 1990. And Cynthia Nevison has just done a really good job of working with us on the epidemiology. There's different ways you can track the prevalence to show that, hey, there's a lag in catching up as more and more people get autism, but it's a real thing that more and more people are getting autism. So with that, I'll thank you for watching and wish you a good day.